Have you ever wondered, while gazing at the starry sky, if all this splendor will one day come to an end? Not just individual stars or galaxies, but absolutely everything. Space, time, matter itself. It's not a question of if, it's a question of when. And the most crucial question that stirs the minds of scientists and science fiction writers alike is this: can humanity, or whatever we become by then, survive the death of its own universe? It sounds like madness, like trying to survive after the house itself, its foundation, and the very ground beneath it have all burned down. But it is precisely in such insane questions that the grandeur of the human mind resides. Let's journey into the farthest future, to the very edge of time, and see if we stand a chance. Friends, before you go, please subscribe to our channel and hit that notification bell. Before we can make any rescue plans, we need to understand what exactly we're saving ourselves from. Cosmologists have several primary doomsday scenarios, and each one presents a unique challenge for our descendants. For a long time, the Big Crunch theory was popular. Imagine our universe is a ball that was tossed into the air. It flies upward, expanding, but eventually gravity takes over, and it begins to fall back down, compressing into one super dense and super hot point. For any life, this would be a fiery apocalypse, where all of existence is crushed into a primordial soup. But recent discoveries have shown that the expansion of the universe isn't slowing down, but on the contrary, is accelerating. The culprit is mysterious dark energy, which acts like anti-gravity, pushing galaxies further and further apart. This discovery gave rise to two other, more probable scenarios. The first is the Big Rip. In this variant, dark energy eventually becomes so powerful that it begins to tear the very fabric of space-time. First, it rips galaxies from one another. Then it rips apart star systems, flinging planets away from their suns. Next, it rips apart planets and stars themselves. In the final moments before the end, this force will become stronger than the bonds within atoms and tear apart everything, down to protons and neutrons. This is the fastest and most violent ending. Survival is impossible in it, because the very concept of structure or object will cease to exist. Fortunately, this scenario is currently considered unlikely. And now we come to the prime candidate for the universe's killer, heat death, or the Big Freeze. It is the slowest, the most melancholic, and strangely enough, the most hopeful ending for us. The universe continues to expand forever. Galaxies drift so far apart from one another that their light eventually stops reaching us. The sky turns completely black. Stars, one by one, burn through their fuel and fade out. First, giants like our sun will die, turning into white dwarfs. Then, trillions of years later, the longest-lived stars, red dwarfs, will fade out. The universe will become a graveyard of cooled-down stars, black holes, and lonely planets, plunged into an eternal cold, close to absolute zero. This is the end of energy, the end of all movement, the end of time as we know it. And it is precisely within this slow fading away that humanity finds a window of opportunity. So imagine this. Hundreds of billions of years have passed. Our sun has long since burned out, and Earth is a frozen chunk of ice, hurtling through the darkness. But humanity hasn't perished. We long ago abandoned our home cradle and migrated to new stars. Our final bastions have become red dwarf systems. These small, dim stars are true long livers. If our sun lives for about 10 billion years, a red dwarf can burn for 10 trillion years. That's 1,000 times longer. Around such eternal flames, the last civilizations will huddle. Life here will be entirely different. Planets must be very close to the star to receive enough heat, which means they will most likely be tidally locked, always facing the star with one side. On one half, there will be eternal day, and on the other, eternal night. Life itself, perhaps, will exist in a narrow strip known as the Terminator, a zone of eternal twilight between the scorching heat and the bitter cold. Our descendants by then will bear little resemblance to us. Over many trillions of years, Evolution and technology will transform them beyond all recognition. Perhaps they will be cyborgs, capable of withstanding the harsh radiation of red dwarfs, or purely energetic life forms, dwelling in computer simulations. But even red dwarfs have their own lifespan. And then the moment arrives when the very last star in the universe begins to fade. The final natural source of energy runs dry. Is this the end? No, it is merely the dawn of a new stage of survival. When the stars go out, the only sources of energy remaining will be the strangest objects in the universe, black holes. We're used to thinking of them as cosmic vacuum cleaners that only swallow everything irrevocably. But the great Stephen Hawking proved that's not the case. Thanks to quantum effects right at the event horizon, black holes actually very slowly evaporate, radiating energy. This process is called Hawking radiation. The smaller the black hole, the faster it evaporates and the more energy it releases. For the supermassive black hole at the center of our galaxy, this process will take an unimaginable amount of time. 10 to the power of 100 years. That's a 1 followed by 100 zeros, a number that doesn't even have a name. It is precisely around these slowly dying giants that the final civilization may assemble. Imagine a gigantic Dyson sphere, built not around a star, but around a black hole. This structure would capture every quantum of energy emitted by the dying monster. This energy would be infinitesimally small compared to stellar energy, but for a super-efficient civilization of the future, perhaps living in a virtual world where the speed of time could be slowed down, this could suffice for an eternity. They would be able to sustain their existence for googles of years, observing the slow decay of the last structures in the universe. They would become a twilight civilization, living on the residual heat of a dying world. But even this won't last forever. Sooner or later, the last black hole will evaporate, and then the era of matter's own decay will begin. Some theories predict that even protons, the building blocks of everything we know, are unstable. Their half-life is colossal, possibly 10 to the power of 36 years, but it's not infinite. In the infinitely distant future, all matter, cooled stars, planets, cosmic dust, will simply dissolve into an ocean of elementary particles and radiation. The universe will transform into an absolutely homogeneous, cold, and dead soup. This is the true heat death, the end of all complexity, all information, all life. This is it, the final curtain. Can anything survive such a fate? Here we step beyond the bounds of known physics and enter the realm of the boldest hypotheses. If a future civilization reaches a level of technological development that we cannot even begin to imagine, it may face two paths. The first path, to become creators. What if, by harnessing all available energy, for example, from the evaporation of a black hole, we could create our own pocket universe? Some physical theories, such as the theory of inflation, suggest that creating a new universe in a test tube is theoretically possible. This would require concentrating a gigantic amount of energy into a tiny point in space to trigger a new Big Bang. This new universe would expand in its own dimension without affecting our dying one. Our descendants could become its creator gods, set its physical laws, and, most importantly, migrate into it to start everything anew. This would be the greatest act in history, not merely to survive, but to give birth to a new cosmos, becoming the seed for new life. The second path is not to create something new, but to find something that already exists. This is a path of escape. We are talking about the multiverse. The idea that our universe is just one of an infinite number of other bubbles within a gigantic meta-universe is becoming increasingly popular in theoretical physics. What if you could build a bridge to find or create a wormhole that would lead to another young and energy-filled universe? This is absolute science fiction today, requiring the control of energies comparable to the energy of the universe itself. But if you have trillions upon trillions of years at your disposal, perhaps you would find a way. It would be similar to how our ancestors crossed oceans in search of new continents. Only here, the ocean is the void between worlds. and the new continents are entire universes. Of course, all of this is merely speculation based on our current, very limited understanding of the world. Perhaps there's something we don't know. Perhaps there's a cyclical nature we're unaware of, and after the heat death, a new Big Bang will somehow occur. Perhaps dark energy isn't a constant, and in the future, it will change its properties, leading to a completely different outcome. But the very thought that the mind can peer so far ahead, even crafting plans for the end of all existence, truly staggers the imagination. This isn't a tale of unavoidable doom, but of incredible resilience. It's a story about how, even in the face of absolute emptiness and eternal cold, the spark of consciousness will seek a way to keep burning. We are the universe, attempting to comprehend itself. And perhaps our ultimate purpose isn't merely to be passive observers of its life and death, but to become active participants, capable of rewriting the finale. Perhaps the last light in a dying universe won't be the light of a fading star or an evaporating black hole. Perhaps it will be the light that we ourselves ignite, opening a door to a new dawn, to a new universe. And even if we fail, the very attempt to do so will be the greatest achievement in the history of the cosmos. After all, the main thing isn't the destination, but the journey itself, especially when that journey lasts until the very end of time.